We're going to talk a little bit about Unix operating systems, or specifically what the file system looks like in a Unix operating system, and then how we navigate it. That is, from a terminal window, how we go about moving from one folder to another, creating new folders, moving files, etc. So I'm going to use Unix and Linux interchangeably. Strictly, Unix is a standard, meaning it's a set of definitions for what a Unix operating system must look like, and Linux is just one implementation of that. There are other implementations, but I'll use the two words interchangeably. Of course, most modern Unix distributions are, in fact, some version of Linux or have a Linux kernel. In Unix, everything is a file. So in terms of how the operating system, it doesn't matter if it's a folder or a peripheral device. It's going to treat it the same way in terms of how you move things around, interact with them from a terminal. There are three types of files. An ordinary file, this is the file that would include like text files, binary files. It contains some stream of characters. A directory file, or also known as a folder, and inside each directory or folder there could be other directories or other ordinary files or peripheral devices. Again, a peripheral device could be like an external hard drive, a DVD-ROM, even those aren't as common anymore, printers, other things. Again, they're going to reside inside of some kind of directory structure, and we'll treat them as ordinary files. We'll treat them as files in terms of how we interact with them, move them around, delete them, other things from the command terminal. So the Unix file system can be viewed as organized into like an inverted tree, with the root of the tree being the backslash, right? So that's called root, and any directories that are under that, and if you go to the root directory, they're often common system directories like bin. This is where binary files are stored. Dev, again, these are your device files, possibly printers or something like that. Home, these are where your user accounts are stored. So in this example, Romeo and Juliet are users, and each of those would have their own files associated with them. Lib, these are library files, that is compiled sets of functions, other things like that. A really common one is user, and inside of user, one important one is user local. So on the terminal, if we wanted to go to the path user local, it would be user/local. Anytime that you define a path or from the root, this is called absolute. We'll talk about what relative paths are shortly, but if we include the whole path, meaning it starts with root, then it would be the absolute path. A note about user local is it's commonly where you would install, or a system administrator would install files that would not be touched in an upgrade. So if you had your own libraries or binary files, executable files that you compiled yourself for your own purposes or own individual use, you might stick them in user local. So, and then when you upgrade the kernel down the road, user local would not be touched by that upgrade, whereas a lot of other files you can't make that guarantee. So again, we talked about relative path, absolute path names. A relative path name is either a single dot, which represents the current directory, or two dots, which represents a parent directory. And I think the best way to demonstrate this is to go on and move over to a terminal. So we're going to access a terminal from Jupyter Lab. If you open Jupyter Lab, the launcher will give you access to the terminal window, which will open here. Okay, and so we're going to go through several commands. We'll kind of take a back and forth approach between the slides and the terminal window, but the most basic, one of the most basic commands in Unix is pwd. So that stands for print working directory, and will show you the absolute path to the current directory that you're working in. Another common command is ls. So if we do a listing, it's going to give us a listing of the files in this directory. Now, there are apparently no files in the directory that I'm working in now. However, if we do a long listing with the ls-la, then we can see that there are in fact some so-called hidden files. Hidden files in a Unix file system start with the period. So the period there is a hidden file. So if you ever see a folder like this is a directory that it's hidden, meaning it doesn't show up in the file browser itself because it starts with a period. The period here, these are the two shortcuts or relative paths that we just discussed on the slide, right? So the single period represents the current directory, and the ... the two periods represents the directory that's one above us. So again, I think an example here will show us the best. Anytime you're on a terminal window and you want to clear the view, you can simply type clear. And it will clear the view. So I think the first thing we'll do, and we'll get to we have some slides coming up that specifically call out these functions. But if we create a directory with make directory, so make directory, I'll just call it test directory. And then if we do a listing, we'll see in blue there test directory. We should also see it appear in the file browser. There it refreshed. So we see a directory over here in the file browser. And we can then move into that directory with a cd command. So cd stands for change directory. So we change directory into test directory. And now we'll do a listing there. And there are no files here. But if we do a long listing with ls-la, we can see that we have our two shortcuts again. So the ... represents the directory above us. So for example, if we wanted to do a long listing of the directory above us, that is the home directory that we just came from, you can see here those hidden files, those same hidden files that were listed earlier. So again, we'll clear the terminal window. So we have now created a directory. We can do print working directory. Remember, print working directory will show you the directory that you're currently in, and ls lists the files that are in that directory. There are no files in this directory, but let's create a few. We can do that with the touch command. So we'll say touch, and I'll just say file1 .txt, file2 .txt. So here I've created a couple of files. Now if we navigate over inside of test directory from the file browser, you can see the two files that I've created. Likewise, you can list them on the command line and you'll see them there. Okay. So returning to the slides shortly, again, here's an example where we listed a print working directory, changed into another directory and printed that, and again, then changed back using the shortcut ... and printed the current working directory. So we've already seen make directory. We use it to make test directory. We could also use it to make multiple directories at once. And we can use it to make directories that are inside of other directories. As long as the first directory exists, we can do that in one command. So again, let's look at an example here. I'm going to use cd ... to go back to my home directory, where we have test directory, and in this case I'll make another directory that I'll just call test directory 1, and a second directory test directory 2. Again, those are made all in one shot from the command line. We see the three directories there now. We can also create a directory inside of, say, if we wanted to make a directory test directory 3 inside of test directory 1, we can do it with that command. What we cannot do without additional arguments to make directory is to create a directory inside of a directory that doesn't exist. So say we want to create a directory test directory 5 inside of a directory test directory 4, where test directory 5 does not exist, right? So you'll see we'll get an error if we do that. However, we can add the option -p, which will force it to make the parent directory. So now you'll see that we have test directory 4, and inside of test directory 4 we have, inside of test directory 4 we have test directory 5. Also, when you're using Unix, it's useful to use tab completion. So most modern Unix systems will have this feature enabled. So what we can do is, as we begin to type, we can type ls, and we'll just type enough of the directory name to be unique, to make it unique. So if I hit tab right now, it'll autocomplete up to the point it's unique. Okay, but in this case, we have test directory 1, 2, 3, and 4, so we have to specify which one we want. We can specify 4, and then we can begin to type some more and hit tab again, and that will autocomplete to the end. So that's called tab completion. Again, we can remove directories with the command rmdir. However, this only works if the directories are empty. So returning to the command line again, test directory 3 should be empty. So if we use rmdir test directory 3, we'll say test directory 2. In this case, it's been deleted. However, it will not work if we tried it on test directory 4, and that's because test directory 4 is not empty, right? So it gives us a warning that it's not empty, and it fails to actually delete it. We can actually use a stronger delete command, and that is just remove. So if we say remove -r, then we can actually move a directory that, including the R stands for recursively, so this will remove the test directory 4 and any directories inside of it. So now we see that test directory 4 and test directory 5, which was inside of test directory 4, are gone. So if we want to copy files from one location to another, this is we can do that with the cp command. So moving into test directory where I created file 1 and file 2, I can copy those to another location. So one example is I can copy file 1 to another file in the same directory called file 3, like so, and then we see file 3. We can also use the relative paths as we learned before, so I can copy, say, file 2 to the directory above me. And so if we ls the directory above me, we see that file 2 is there. We can also use the absolute paths, right? So the directory above me, the directory above me would be home John, state partition 1 home John. So I can use the absolute path to copy files. So if I wanted to copy file 3 into the directory above, and then I could basically type the whole absolute path. And in this case, that's actually the location I want to copy to. The thing I want to copy would be the first argument, so file 3.txt, and we'll copy it into that location. And again, we can then see that that actually occurred. Okay. If you want to move directories, however, we have to use the -r option. So if I want to move test directory 1 to test directory 5, you'll see I get see that that doesn't work. So what I actually have to do is use the recursive option -r, and now we see that we have a test directory 5. And if we go and navigate or look what's inside it, it should be everything that was inside of test directory 1. Okay. So in that case, that is true. We can also verify that on the command line. And again, that is the case. So that's how you copy files and directories. We can also move them. Move is kind of you can think of move as a sort of a renaming utility as well. So if I want to move the directory from one location or a file from one location to another, I can do that. So in this case, I'll move file 2 to say file 7. And you notice now file 2 is gone. It's been replaced with file 7.txt. Again, we can use this command to in combination with absolute or relative paths. So we can move file 7.txt into test directory 1 like so. And now if you look inside test directory 1, we should see file 7, and there it is. Right? We can use this in combination with other, absolute or relative paths, any of those things. Again, we talked about how to move directories. It's no different with the remove command here. So if we want to remove a file, an individual file, we can just say remove file 3. As an example, I think I have an example coming up for wildcards. So what we can do is create quite a few files again. File 2, file 3.txt. With that, we can use so-called wildcard to do file matching. So imagine we want to remove all files with the .txt file extension. In that case, what we can do is we can remove basically everything using the asterisk as a wildcard operator to pattern match everything with the .txt file extension. And you see that everything is in fact gone. So there's an example of the wildcard. You can protect yourself if you use the interactive remove. So let's say we wanted to remove some number of those files. What we could do is say remove, give it the -i for interactive, and then it's going to prompt us for every file we want to remove. So say we want to remove file 1, file 2, not file 3, but file 4 and 5 as well. And so there, it leaves that behind. Okay. You could actually alias the remove command itself. Alias means to create an alias. So the best way is an example here. So we can alias remove to be equal to remove -i. This would force all instances of remove to actually be called with remove -i. So in that case, if I bring the files back and run the same command, remove, this time I'll leave off the -i, and you'll see that I'm prompted for it every time as if I had typed remove -i because remove has been alias to remove -i. So in this case, I will say no to all of them. And I can see what my aliases are with the alias command. In this case, I only have one, and I don't want to leave it like that, so I'll say unalias remove. So that's how we delete files. Obviously be careful when using remove if you had the correct permissions, and most likely you wouldn't. But if you were a user that had the correct permissions and you did remove recursively, forcefully to override the -i option or anything that may be in place, /*, this would remove the entire hard drive. And there is no recovery from remove. It does not move the files to a trash can that's waiting to be emptied or anything like that. It's an actual hard remove. So be very careful when you do this.